All right, let's do one more example where we'll write the equation of a given line. And in this case, we're actually going to generate a new line using some given data. And then we'll use it to make a prediction. That's kind of foreshadowing what the next unit is going to be later on in April or May. But this is a good application for us to look at. So each year, the U.S. Department of Commerce publishes a survey of current business. Included in the report is the average personal income of U.S. workers. This is an indicator of health in the economy. How could you use the data on average personal income in 1980 to 1970 to predict the average income in 2010? Why don't we go ahead and make this 2020 since that's our current year. We'll just change the year we're looking at. So here is the data from 1980 to 1997. So in 1980, 0 years had passed since 1980, and the average income was just shy of $10,000. By 1990, 10 years later, the average income was just about double at $18,000. And 17 years later, 1997, the average income was around just shy of $26,000. So then our question now is, what's the average income today in the year 2020 if this growth continued? Which, of course, we know, right, this would be the year 2000. So we know right around here is 9/11. That hurt the economy significantly. And then we had the recession in 2008. And maybe not. We're heading into another one right now. We'll find out. Let's hope not. Right, so probably these major events are going to keep this growth from continuing. And we'll talk about, when we get to modeling, about how it's dangerous to make predictions so far out from the measured data. But just for the sake of practicing the algebra, let's go ahead and do it anyway. So it says find a linear equation that can be used as a model to predict the average personal income for any year. So we want to write a linear equation that models this data, that follows this data. So this is, like we've talked about in science classes and other math classes throughout the years, your line of best fit, the single line that goes through or as close to all the points as possible. And we want to write the equation for that line, right? That's what we're looking for. Well, we know that in order to write the equation of a line, we need to know either the slope and a point, or if we know 2 points, we can find the slope and write the equation that way. So that's what we're going to do here. So we're going to say, well, I don't know what the slope is, but I do know that the line of best fit should go pretty closely through all these points. And what if we just say, for the sake of estimating, we'll go exactly through this initial point here, and then exactly through this final point here, just to get an approximation, right? That's fairly close to all the points, and it may not be exactly what the line of best fit is, so you stats students who want to do the least squares regression line, don't worry, we're just approximating here. So what we know then is that we have these 2 points on the line, right? Specifically, those 2 points are 0, 9,916, and this one is 17 years later. The average income was 25,660, right? So here are our 2 points that we know on the line, okay? Which means we can use those to find the slope. Slope is y2 minus y1 over x2 minus x1. So our known y values are 25,660 minus 9,916 all over 17 minus 0. And then I can just compute that value, right? So 25,660 minus 9,916 is not what I typed in, is 15,744. So we'd have 15,744 over 17. So just divide this by 17. Sorry. Did it a couple times on accident here. We want that guy divided by 17. Sorry for that. Same thing. 926. Okay. So our slope is just about 926. In context, that means every year the average income is increasing by about $926. So on average, in that 17-year window, the average person was receiving about a $926 raise on average. Okay, which is pretty high probably for long-term patterns in that era, and again have probably been curbed by certain economic events since. But let's see, we know now the slope, and we know now multiple points. All of these are points on our least squares regression line. Well, we picked the one specifically that goes through the first and last point. Let's take the first point because it's got smaller, easier numbers to work with. But using our point slope form that we learned about in the last video, we can say y minus the known y coordinate. So in 1980, the average income was $9,916. We saw a $926 increase per year starting in 1980, which was 0 years since 1980. So then our line would just be, let's do this in 2 steps. Y minus 9,916 equals 926x, and then all we have to do is add 9,916. So our equation would be 926x minus 9,916. This would be the equation that would allow us to predict the average income in any given year after X years since 1980, right? So there's part A. Part B, we can actually put it into practice. Let's see. So in 1980, that's when we started our measurements. So in 2020, that is 40 years since 1980. So we're going to go ahead and plug 40 into our equation. Real simple. And let's see what we get. 926 times the 40 years that have passed since 1980 plus the 9,916, which was our starting average salary, says that the average U.S. income would be around $46,956. That's about what we would expect the average income to be in the U.S. if, big if, the growth from 1980 to 1997 continued consistently all the way through that 40-year period. And again, we saw some big hits in the last 20 years that probably curbed this growth. Probably it looked more like it went up for a little while and then it kind of flattened out for a little while and then maybe went up again for a little while and flattened out. Kind of probably does more something like that in real life. But 46,000, 47,000 is what we would expect the average salary to be if growth of that kind had continued since 1980. Anyhow, this is a good application of linear growth functions. Again, in the next chapter, we'll talk in much more depth about how to use models, how to use data to make models, to make predictions. This chapter, we're really just focusing on can you write equations of lines and do the basics. So tonight in the homework, or I should say in these practice exercises, there really won't be word problems of that sort, the applications. It'll just be the discrete examples like this where we just say, here's a specific point, here's a slope, find the right equation of the line, and you've already got a head start there with number 17. So there is our section on writing the equations of lines.